Okay, let us again have a round of applause for Oksana.
The stage is yours.
So, hi everybody, I am Oksana and I am psychoanalytic at Under Defense. So, monitoring and detection is precisely what I am doing pretty much every day. And today I would like to raise certain issues about these processes, and I think those are worth your attention. Within various projects you may have different environments, different scope, types of scope, number of machines, computers or devices to be monitored. You may have different threats which are a priority for this particular environment, but still detection and monitoring problems are more or less the same. Let us say all your capabilities about threat detection depend on three factors. First of all, it's about data sources. Second is about software, tools in use to monitor. And third is expertise of those people using that software and working with those data sources. I'd like to raise certain questions which, in my view, are of crucial importance and have to draw your attention within these three processes, and I'll tell you more about those. First of all, data sources. Now, everything has logs, starting with operating systems to coffee machines. But before using those logs to maintain security, you have to pay attention to certain questions to raise about your environment, and you have to get clear answers to those questions. First of all, what is the format of those logs you'll get? There are some generally acceptable formats, well known and well processed by event management systems, while there are also data types which you will have to parse manually, to parse with regular expressions and so on. However, in some systems you can choose the format for those logs to come. This is important, and these features have to be studied before you start monitoring any technology. Second is about improving the logging in the system. You look at the data that you get and you understand that potentially it may be not enough to cover some security incidents, and in some big systems it is possible to use so-called expanded logging. For advanced logging, you can set up a system in such a way that it will send you some additional data. Usually that sort of data is not logged by default because most users just don't need them, but in terms of security you may actually need them a lot if you don't want to install any additional utilities, which we'll discuss later. As an example, this is a popular and pretty much well known to everybody, is advanced Windows logging. You can get from your Windows operating system a bit broader scope of data than is usually provided. So depending on your use cases, you can look at these logs and choose the sources which you need. However, when setting this type of advanced logging on, you have to be careful and to understand what exactly you switch on, because much of those data may seem useful to document some attack, but while in fact those data would just clog your event management system and will not provide any valuable information to you. It's also worth considering native filtering from logging perspective, because in some systems you're able to use some settings at the very beginning when you start the system whereby you would filter out certain logs. For example, when logging the IIS web server, Internet Information Server web server, you can indicate the fields that you want to see in those logs, and if some of them are of no interest to you and bring no value to your security monitoring, then you just remove them, you switch them off, or you set certain conditions under which logs have to be stored and continued. So it's better to define all those things at the very beginning in the system itself. Of course, later in your event management system you will have these features too, and you will be able to find the information you need, but it is even better if all those conditions are set starting at data sources. Also of crucial importance is a question of how exactly are those logs collected in the system. In some cases, logs may serve as not only monitoring data, but also they may have some critical important data. There may be some information which has some business impact on the company. So how logs are transported from the system, how they come to you, has to be watched over. It's possible to send logs encrypted, and if you have such features in your system or in your device being monitored, of course you definitely have to use them. As an example, in Windows, in senior versions of Windows, it's possible to encrypt logs, and these features are not set by default, so you have to look at them and raise this question whether it's worth setting it, switching it on so that no critical data would get lost and would not be received by offenders, by bad guys. So you sorted out with what you have at the beginning, you have sorted out the data sources, you have set up the whole environment in such a way that it provides you with the maximum amount of useful information which would help you in your security monitoring. However, sometimes you need even more data, and you may need some additional functionality, additional features, additional software, and it exists in sufficient amounts, and I believe that this industry will continue to develop in the years to come. What's worth paying attention when setting up such software? First of all, it's proper timing for reports, for reporting in that software utility. What do I mean? When collecting data, acquiring data from the system, there are fundamentally two approaches. First of them is about logging events one by one, in chronological order, all events that happen in the system. The second is about collecting certain lists, making lists of what you have in the system, some inventory of what you have in the system, and then you detect what has changed and what are any anomalous changes. In the first case, that's how most logging systems work, but in the second case you may run into a situation which is not so good, because to collect such information, scripts are always often used. Since this is a proven method, it will work pretty much always work, but there are two big questions about this method. First of all, it's about timing. Timing is about how often should that script run to collect information from your environment, information that you have to receive, information you have to compare with what you believe normal and adequate for that environment. What do I mean? For example, you want to have your monitoring as real time as possible, so you run that script of every 30 seconds. So after every 30 seconds there is a script running your machine, collecting those logs, sending them out, and usually those logs will be exactly the same. It seems that you see the system, you have event management system full of logs which will be completely the same, and they will not provide any useful value they would have to bring. This is one thing, one factor. The second factor is this: it's preferable to have those data to be unique. For example, I show Square here, which is Facebook monitoring software utility. I provide it as an example because I like their approach towards collecting such information. And in a query something appears, it uses intervals. So again, you can say that, for example, every 15 minutes certain data will be collected. However, during those 15 minutes you will not lose visibility of the system. So in 15 minutes, OS query will tell you about all those changes within those 15 minutes. Unlike scripts, because a script would just run after a certain period of time in a stable way, and you lose visibility during that period of time. And during that time, a potential offender may potentially be able to do within that 15 minutes whatever they wanted to do, and you will still get the same data you got before that. While with OS queries there is an option whereby only unique values will be logged as collected from the system. So every 15 minutes, for example, it will collect data about USB devices that were connected to the computer, and if in 15 minutes the number of those USB devices does not change, you will not get any log. The next log about USB devices will only be sent to you when you connect a new device. So you eliminate the possibility that you'll miss something over the time, while at the same time you only get unique data which are of some value to you. The second factor is custom-made configuration. These tool sets may be very important. Proper configuration of such tools could be very important. As I said, it depends on what you collect and in which amount. You can do some filtering. If you haven't managed to do filtering in the system itself, in the system from which you collect logs, then at least with configuration and monitoring tools, you are able to make your wise choice. Currently, there are many configurations like that for many utilities. They are actively shared, and they're generally known examples like sysmon config. Like if you have this bare utility and you need some configuration file which will remove whatever is unnecessary, some basic indications that the operating system is working, while at the same time some security interests of potential interest to you would be logged. That's the config that you need. In a similar way, for ODD, Linux monitoring utility, so you have to see what are the options for custom configuration for your monitoring utility, while at the same time look at what others are offering. For example, it may be that you will not be happy with configurations that other researchers offer to you, but at least you will understand where to start from. Next part. Protect whatever you use to collect the data. It is well known that a great amount of various malware sometimes has hard-coded names of services or antiviruses, so that when entering the system it will try and kill them. And the same now starts applying to monitoring utilities. For example, sysmon, from my previous example, has been abused for quite a long time by various attackers. That is to say, they try and unload its driver and stop its processes. Sysmon tries to do something to resolve those problems, but sometimes these attempts are not enough. So, if you now forget about the context of a particular utility, you have to make sure that your monitoring system will not be switched off automatically by the offender in some way, while at the same time it will let you know that logs do not come anymore from some reasons. Most endpoint protection tools and most monitoring tools have some sort of, say, last log, firewall log, when they say that the service has stopped. You have to pay attention to such things, and there should be automated detection attached to such things. Or you have to fix them in the system somehow. You have to make sure that whatever happens, your monitoring software, utility monitoring tool will be able to start after it was forcefully switched off, or after there has been some failure in the system. You have to monitor such things, and you have to look at these things. You have to monitor whatever monitors your system. So, you have your sources, you have your monitoring tools, utilities, which help you expand those data sources, and now you have to need people to understand which data you got, what they mean, and what is the top value in that day, in those data.
потенційно можна розширити цю саму
How could you potentially improve and expand that expertise? What to read, what to do, what measures to take? First of all, there is this attack matrix framework. Please raise your hand if you heard about it.
От на сьогоднішній день є тенденція така, що чули майже всі.
Currently, the trend is this. Almost everybody heard about it. Attack matrix is a framework which basically generalizes most of the attack types that may happen at various stages and kill chain. So Metro is a non-commercial organization that collected all information available from statistics, from reports on active cyber criminal groups, malware, and operating system features, and they have brought them into some order depending on the stage at which these things may work. It's very convenient to use Metro attack matrix framework to expand your own list of use cases. For example, if you are unsure that maybe you don't monitor something, maybe you don't know something, then most probably it would be useful to you to read through some items to learn more about techniques described here and to understand how to better arrange logging in your system, how to better structure, how to better create your protection, or where to start from. This is not any less important. Also, in addition to you being able to learn those things on your own, there are also people who have already done it for you. They have already launched it and done it, and they have published those data with open access. So you have to monitor research related to detection. It's also quite important, and one of the brightest, most effective examples is the research by Japanese CERT, detecting lateral movement. They explain in detail what happens to the system when certain utility starts. The first research explains about something about utilities and attacks, while the second research is more about general activities, general actions in the system. So they are analyzed in terms of event codes, the files that remain after they have worked, and how certain action has been done. You can do it on your own, but it is better in such cases to use expertise of some people who have already done it for you. So if you decided to do it on your own, if you want to simulate somehow your threats, to check your level of security, of protection, to check your monitoring and detection capabilities, then most probably you will need some environment, some test environment. Look, to simulate threats in some production environment is not exactly what you want to do. Some suggestions that we had when started creating our own environment. First of all, it's about the use of making use of virtual machines, because in that way you'll be able to make more iterations and then to roll back to the stage where the system was not affected by any change or attack as yet, if needed. Second, you have to remember about different OS versions, multiple OS versions, Windows and Linux versions. They're all important. They may respond in completely different ways to various actions, so it all has different features. It also applies to data source research. To better understand your data sources, it's preferable to test various types in your test environment to understand what are their weaknesses, strengths and weaknesses, and maybe to learn something new for yourself, so that when you provide monitoring in real environment, real life environment, it would be easier for you to get adjusted and understand what you need and what you don't. Also, sometimes it is important to remember about the diversity of updated versus non-updated machines, because there is a huge number of threats to appear, and sometimes you have them in their full spectrum, full range, to see that they will work. So it's preferable to have both versions of operating system that may be affected by a certain attack. An isolated network, if you believe that something may potentially harm other machines, And many software products, popular software, just to create some general noise background, so to say, so that during the testing you understand how the legitimate software works, although we'll discuss it a bit later. This is an example of that lab environment that we have created at some point in time for our company. And there are these conditions that I mentioned. Okay, then you may run those tests in different ways. One of the options is to use so-called attack simulators, and now we are getting even more of those. I provide some open source solutions here, the ones which we used at the very beginning, and we analyzed them for ourselves. As you can see, there are many more solutions of the type than you see in this list. They exist for various platforms, for various attack types and various involvement with your environment. Starting with simple scripts, which will just run certain commands, up to sophisticated virtual machines, which contain a lot of pen testing utilities that have to be used in order to test the reliability of your monitoring. So this industry has been fast growing at the moment, and in fact this helps us a lot in such testing. Here we don't mention Red Hat OS, which contains about 9 other virtual machines, so this is some sort of an assembly combination of those simulations, and when you install it you will have something in your environment with a full range of this full list and even more of what you see here.
Besides that, when carrying out the tests, you can use the practices suggested by MITRE itself for testing and monitoring different products. They call it evaluation. There are many endpoint production solutions and monitoring solutions, and you can pass all those solutions through MITRE evaluation. The software in this case is installed in an independent environment and tested for its capability to counteract to all the attacks listed in the framework. After the first row of evaluations, MITRE has published the methodology list of attacks mapped to the environment that has been used during the evaluations, and they also published the description of their system downgrade, which was necessary to be unbiased in understanding which solution is better for the system protection. They described in detail all the actions performed on the systems, and you can use it as an example when arranging testing your own system. And the last point, which is closer to real life than to the test, is knowing what exactly is the environment doing without any attacks and manipulations. In a normal mode, it's possible to do some simple things, not harming the environment integrity, even in the production environment, to get better understanding, like connections, outbound or inbound connections, user accounts manipulations, and configuration changes that can result in some or other consequences. I would like to say that not only large-scale threats should be monitored, but also lesser changes that cannot harm the system, but are capable of doing something in it. Or you should monitor the system as it is. When you investigate so to say, default services, you have better understanding of operating system actions to avoid false positive, so that your detection never touches the natural features of the system. To sum up, I'd like to say that first of all, you have to understand what you have, what logging capacities are there in the environment before you start installing the protection software. Next, you should collect as many data as possible, but you should be able of filtering data to get rid of irrelevant data. The filtering is related by the threats that can be used or can be realized for some or other environment, because the threats are very diverse. You have to know, to understand, and if possible simulate the threats to check yourselves, to know better what you see, what you don't see, and what's relevant to the protection. I think that you should check your rules for RTP connections. It's just my intuition. And to understand better what is natural for the system, have a look on its operation, of its functioning, to understand it better. It will be helpful to avoid inconvenient and unnecessary investigations of the false positive, to avoid waste of time that should be used in some better way. I would like to thank you for your attention and to thank my team, which is involved in real-time monitoring. So I know that they are listening to the stream, but they could not come here. Thank you. It was great. And you are a super speaker, not having your own monitoring. And I like the idea to have a look, have an eye on monitoring tool. So how many monitoring levels should you have to monitor monitoring tool and so on? The more the better. By the way, I did not mention Sysmon service, which is very difficult to disable. You see, when a malware finds a Sysmon process, it tries to kill it, and after that, this process is disabled. We see it in the logs, but we are also able to explain to Windows that after disabling the service, it should be immediately enabled again in 0 seconds. It's a funny way to do it, but you should think about it in advance and use different watchdogs. Do we have any questions? Yes, we do. My first question is as follows. I did not understand what sense does it make to reinvent the wheel. I mean, you can use many CM systems, SAM systems, capable of doing the same things that you described and many more. Well, actually, I am using CM systems, but these actions are necessary just to prepare data for CM. A separate topic is how to configure CMs to be capable of doing the same things. So I focused just on monitoring. Well, as far as I know, there is no preparation. Many CM systems are capable of collecting data. Yes, okay, but which data? are going to CM system? How do you configure the alerts saying that this is a threat and this is not a threat? How do you know that there are no false positive on the default system operations? It should be understood and configured. Okay, no CM is a magic box. I see many hands up. Thank you for your presentation. My question is as follows. Did you ever think on doing all this in automated way, to automate analysis of the regular system operation with the use of machine learning? One more question. If an attack is masked as if it were a normal operations, well, first answer, the machine learning is in the trend, and the system with the machine learning is capable of analyzing something, but as an expert, I better understand everything myself. Besides that, a human is necessary to teach the machine learning and to explain what activity should be considered normal. And can you repeat your second question, please? My second question was how to counteract the attacks that are masked as if they were regular system actions. You see, if your system does not react on normal functions, you can also lose the attack. Well, okay, you should set up the largest possible number of normal parameters to make your exceptions targeted. Then it's possible, and you should have an incident response plan. No system is ideal, and you should dig down in some processes to understand that a change in 2 or 3 values means not the natural activity, but something completely different. Hello. I have the following question. Do you have any ideas how to counteract log fuzzing when a perpetrator generates so many events that your monitoring systems lag behind or do not work at all? And in the meantime, he does what he wants. Well, first of all, there are many logs so large, or there may be so many logs that it will overload the server that collects the information. Then, fuzzing has usually some pattern, and as soon as you see a pattern in the logs, you should filter it and to have an eye on real things. I understand your point. We had a case like this in testing environment, and we get to understanding that the default logging can be compromised. For this case, you have utility software which collects the information on attacks, and these utilities are harder to be compromised. Thank you very much. Hello, Oksana. Thank you for your great presentation, and I would like to ask the question about MITRE attack metrics. What are your recommendations for the beginners? What is the order of moving, so to say, over this matrix, where there are 10 or 12 tactics and hundreds of techniques. So what is the action order? Well, we have passed it already. So first of all, try not to use the techniques and tactics that are out of scope. There are things like rootkit actions or preparational actions that they are out of your monitoring scope. So first of all, think about the tactics and techniques that may be realized in your real life. Study the testing utilities. Think about the attacks that can be performed automatically by a script or a virtual machine. And if you find something interesting for your specific environment, do it manually or find some guides about the manual simulations. I'm Denis Kravchenko of Ericsson Company. We often work with the telco companies audited by Big Four audit companies for security. And we found out that the auditors have very bad attitude to some point. You were right in saying that the monitoring service should be used to save a little bit on CM licenses. But coming back to auditors, they would ask, how would you guarantee that your tools installed before CMs never change the logs? How can you guarantee the integrity of information that is processed by your tools and by your intermediate servers? Well, we can use minimum file integrity monitoring. We have already mentioned monitoring the monitors and encryption, logs encryption. Are we going on with the questions? Yes, I have another person who wants to ask questions. But this is the last presentation before lunch. Please be reminded. Thank you for your great presentation and delivery. My question is a follow-up to some other question. When the attackers try to simulate a regular operation of the system and how to counteract to such attackers, I think first of all you should do behavioral analytics. For instance, there are a few requests, but it's normal, but it's not normal where you have megabytes and megabytes of requests. So what behavior analytic tools would you suggest to monitor abnormal activity? Unfortunately, I don't know any utilities or framework capable of doing this. We were basing on our expertise in setting up the detection of abnormal behavior. There are some things that are going on in the system, and you may keep them under monitoring just knowing that they are normal. I don't know any centralized solutions to find out the behavioral abnormalities. Thank you. I think we'll stop the questions and answers and upload Oksana.